So we're going to learn about bearings and headings. What they are is just different ways of describing the direction of something. So the point of it is like an airplane. They describe the direction it's going based on either bearings or headings. Bearings are supposed to be the compass bearings, like with like north, east, west, south. Even though the notes don't say that, they're supposed to. And heading is supposed to be something a little different, which I'll get to in just a second. Okay. So, whenever we're talking about the unit circle, and I'm talking about the unit circle in degrees, where do we start? Where's 0? Not the top. You can't imagine us doing so well. On the right here is 0, and it goes over like this. That's the unit circle. Okay, that's directional. If we're talking about heading, this is actually going to start from the top, and it's going to go clockwise. So heading is different. And then compass bearing. It actually, since that's north, that's south. Did we know these? North, south, west, east. We know that. Yeah. People get these wrong because they forget what west and east are. Okay? It's we. It's we. It's not you. It's we. We. No, see, that doesn't work. Because you say never eat. Okay? Never eat soggy waffles.
You just go to the right.
Why did you go to the right?
Well, because that's the direction.
You go clockwise.
But for the unit circle, you go the other way.
But this is a compass.
Yeah. Everything else is clockwise, but the unit circle. So unit circle to me.
Whatever, so this is going to start from here and go this way, or it starts from here and goes that way, or it starts from here and goes that way, or it goes that way, depending on. So if we're northeast, we go this way. If we're northwest, we start from north and go that way. If we're southeast, we start at the bottom and then go towards the east, and if we're southwest, start at the bottom and go that way. So these are the directions that we need to know. So this first one is an example. Now, the example's wrong that they give you. There should be no arrow up here. Okay? So this is a plane that's flying on a heading of 120 degrees at the speed of 200 miles per hour for 2 hours. So if you notice, starting at 0, we find where 120 degrees is, and we're going to go out that direction 400 miles. Why am I going out 400 miles? Yeah, 200 miles every hour for 2 hours is 400 miles. Okay. So let's talk about a ship. This should say heading right here. Typos are really annoying me. So a ship has a heading of 285 degrees at 50 miles per hour for 5 hours. Draw the diagram of where it would end up. So it always starts here in the middle. Now, this is kind of nice because we have these numbers in front of us. So I'm going to go start here and then count over 285 degrees, which is right here. So I'm going to go ahead and travel that along that line. And how far did I just go? 250 miles. So that one was pretty nice because it gave us the nice little circular thing. Well, that's never going to happen ever again. Let's do this without the circular thing. So we have an airplane traveling on a heading of 200 degrees at 300 miles per hour for 5 hours. Draw a diagram of where it would end up. So we always start on an axis like this. Okay, I really don't draw it much bigger than that. Probably end up drawing these much smaller as we go along. So now I got to figure out where 200 degrees is. So what quadrant is this heading of 200 degrees going to end up being in? The third quadrant. Okay, so it's going to end up going in this direction. Now, is it going to be more horizontal or is it going to be more vertical? No, more vertical because it's closer to 180 degrees. So we're going to draw it like this. Okay, so starting from here, and it's going to end at the end of the arrow right there. And how far is that? I suggest you draw these relatively large, especially when we get to the word problems, which are coming up very shortly. I mean, that is a word problem, but Or doing more complex ones. Any questions right now how to draw a heading? Didn't think so. Okay, let's talk about the bearing now. So I already kind of talked about it. So again, this thing is wrong. An arrow going up. Don't know why it's there. It shouldn't really be there. But we have John here who drove north 30 degrees west. You start north, you go 30 degrees to the west for 100 miles. That's why it's ending up with this arrow right here. Okay? Let's talk about Sarah, who swam for 20 miles and is probably dead.
You're not wrong.
Poor Sarah. Sarah, I'm so sorry. Not paying attention. That's just alright, so we're going to start where? South. So we're down here, and we're going to go which direction? East, 60 degrees, which is going to be over here. Okay? So again, we're starting here. And that is 20 miles. I don't really care about the length right now, because it doesn't really change anything. We're just practicing the direction. So now I'm going to do the exact same problem, but without the circle. I'm going to do it all on the axes now. Okay? So Azim walked south, 75 degrees west for 5 miles. What quadrant am I in? Am I more horizontal or more vertical? More horizontal, because I have to go 75 degrees from here. So it's going to look something like that. Okay, so sometimes you put two headings together. Example 7 really isn't much of an example, so there's not much to go here other than just talk about it. So an airplane flies for 500 miles on a heading of 60 degrees, so it shows us that. And then it changes directions and flies for 200 miles on a heading of 150. So it's just showing you how you can start here and fly two different directions to get here. That's all it's trying to do. So where does it end up? Ends up there. So if I were to draw this little dotted line, anybody take physics yet? What is that dotted line called? I haven't heard anybody say it correctly. It's a vector, but what kind of vector? It starts with an R. Rhymes with exultant. Resultant vector. Very good. Alright, so this is the resultant vector. So we started here, we ended there. Okay? It's just showing you that. So now we're going to go ahead and do our own problem. So using an example, it's finding the angle between the flight paths. So it's going to be looking for this angle right here. So again, we're going to draw my resultant. So let's deal with what I do know. So I need to find this angle right here. Any ideas? Okay, do you agree that I'm going to start color coding this thing? We got orange and we got blue. Okay. Do you agree that I need to find blue, and if I add that to my orange, I get the whole angle measure? Do you agree with that? How do I find blue?
It's a right angle.
I haven't heard anybody say anything correct for.
90 degrees.
You saying that's 90 minus 60, so that's 30? They're just making that up. That's voodoo math.
How?
Okay, we're in a geometry room. The geometry teacher even knew that we were learning about this today, so he put it on the floor in the front. For those of you that can see the floor in the front, those are two parallel lines cut by a transversal. So do you agree that this blue right here is equal to this blue right here?
Yes.
Because these vertical lines are parallel, so these blues are equal. No, I do know this blue. What is this blue?
60.
So this blue is also 60 degrees. Okay, this orange right here. This one orange is a little easier to figure out because I'm going 150. So how far away am I from 180 to 150? 30. So what is the total measure? So the total angle measure is 90 degrees. I'm going to just redraw it over here real quick. So there's not so many markings over here because there's a lot going on. So there's my triangle. So that's 90 degrees. I'm going to ask you an extra question. What is the displacement of the plane? Displacement just means the length of the resultant vector. This is a right triangle. There's this theorem that we learned way back in the day by this guy named Pythagoras. So, again, we have from the previous problem, so we do know it's going to be 500 here and 200 there. So, this is 500. This is 200. So, to find the resultant, I just do so 500 squared plus 200 squared. So the answer is 290,000. No, you gotta take the square root of it. Okay. So we're gonna get it was part of the problem. Okay. We good? Hey, it's the units as miles. For giggles, let's find this angle measure. How do I find that angle measure? I don't know. It's only a right triangle. So all this A, you would do tangent of A equals opposite over adjacent. So all we're going to do here is make sure we're in degree mode, which we are, because we're on a geometry teacher's calculator who always keeps it in degree mode. So second tangent of 2. Do I really need to do 200 over 500? Yeah. You can just do 2 over 5, right? Yeah, you know you can do that. 2 over 5. So for this, you're going to get angle A is equal to 21.801 degrees. If I create an angle B, how would I find angle B? Thank you. So that we just, since we know the whole triangle is 180, we already have 90 bits spoken for. We have another 21.81 or 801 spoken for. So you're just going to do 90 minus that previous answer, and you're going to get the 68.199 degrees. So right there. Any questions so far? All right, let's try. Where's Gabe been the whole time? That's a long test.
Well, I guess there's a lot of third testing.
He's missing the whole thing. All right, so a plane flies for 3 hours at a speed of 200 miles per hour on a heading of 120 degrees before it changes directions to avoid a storm. It flies another 2 hours at 250 miles per hour on a heading of 20 degrees. Let's draw a diagram to represent the situation, and then let's find the angle between the two flight paths. When we go to draw these, we have to read the question, use a little bit of common sense. Let's play pretend. Let's say that it said it was going north. Should I start here? Should I start my picture here if it's going north? Why not? Because we're trying to go in that direction. I can't tell you how many times I've taught this course that people are like, Coach, my picture doesn't fit, and it was literally the first thing is going north, and they started here. Whatever. So, this is going 200 miles per hour and a heading of 120. What quadrant is 120 going to be in? The fourth quadrant, heading. So we're starting from the top. So we need to go downward, right? So I can start up here and be fine?
Yeah.
So again, just draw your axes. So we're going in the fourth quadrant. Now, is this more vertical or more horizontal? It's more horizontal because it's closer to 90. Okay, so here we go. We're going to draw that out. How far am I going? 600 miles. 3 hours at 200 miles per hour.
Oh.
Okay, wherever I stop, I actually make another axis here. Okay? And now I'm going 20 degrees. What quadrant am I in? First. Is it more vertical or more horizontal? For how long?
500.
About 500. And again, I'm going to end it right there. And then for giggles, let's draw my resultant. Okay. We need to find this angle right here out. So let's do my color coding. I have blue. I need to find blue. And I also need to find orange. And that will give us our answer. Blue is the harder one. Because when you start from somewhere, you can figure out the degree measure much easier. So how can I find blue? What's the alternate interior angle from blue? This guy right here, right? So if this is 120, how far away? Because I'm using 180 right here. So how far away is 120 from 180? So blue is 60. We agree blue is 60?
Yes.
Again, blue is 60. What is orange? Gave it to us right there. It's 20. So orange is 20. So the answer is going to be?
80 degrees.
So the angle measure is 80 degrees. Now, can I find the distance of my resultant? No, we can't. We don't know enough information yet. It's not a right triangle. Do you think there's a way to do it without a right triangle?
Yeah.
It's called the law of sines. Guess what we're doing after this lesson? The law of sines. All right. Woo! So fun.